Hello everyone, hi, this is Fahad from Future Phones, and today we have a Lenovo laptop to repair, and the model number is IdeaPad L340. I can show you here. You can see IdeaPad L340. So the the first problem with this laptop was the charging port. The charging port was faulty, broken. The customer kept using it in a broken state, and it has caused some shortage on the board also, because I have changed the charging port. You can see here it's a brand new charging port in there, but there is still shortage on the board. It won't power on. I wanted to share this repair with you guys because there is quite a few things to learn. This video could be a little bit longer as well, but it would be worthwhile because in this video you will learn few things, parts replacement, part finding, and parts programming, and the diagnostic of this dead laptop also. How we are going to proceed with this is I'll show you. So if you watch this video completely till the end, you will learn all these things. I can confirm you that. Okay, so you can see now my DC power supply is set to 20 volts and 5 amps. This is a gaming laptop. It takes 20 volts and 6.5 amps. However, our power supply is supporting only 5 amps, so we will give it a shot. I'm quite sure that we should be able to power on this laptop with this power. Okay, we are inserting the power in there, and I will check a few things. The first thing, as soon as I insert the power, you can see the ampere has risen to 0.088 milliamps, which is not enough. So this laptop is not drawing as much power to power on itself. So there is something that is stopping this voltage to be drawn. So what we'll do, we will put our multimeter in the DC range, and we will check if we are receiving the 19 volt first, and we are receiving 19 volt at the power jack. The next thing I'm going to test is the 3 volt power supply that goes to the battery pins. And if I go to the battery pins here, we are receiving 2.39. So this 2.39 is not the correct voltage. So let's see if we are receiving what else we are receiving. Let me go to the microscope and we'll check on the microscope these pins, the battery pins. So we should receive 3 volts. We are receiving 2.385, 2.385, 2.385. So we are not getting 3 volt at these pins. These are the SDA and SCL lines, and the battery present line for the battery. So we receive the first 3 volt LDO at these battery pins, If we do not receive, or if they are not available in exactly as 3 volt, then we have to look for why we are not receiving 3 volt LDO. So that's the first thing. Now we will check, we'll go in the, there is few more things. Let's see how we proceed with this repair. Okay, let's check the power on these coils. These the 5 volt is present, 3 volt is also present, but this is the regulated power. This is not the LDO power. Now let's go on to this one. Okay, so we are receiving 3 volt, 5 volt, 3 volt, and we are not receiving anything else from here. So our 3 volt and 5 volt is being generated, but our 3 volt LDO is not complete, is less than what it should be. Okay, let me take you to my schematics. So these are the schematics. Let me see which one is it now. So FSG541. Okay, so our, if we go on the top here, L340 RH, and what we are looking for is this. So this is the power plane of this board, and we have in the AC only state, we should receive these voltages. If you see here, AC only, and we should have, where this 0 is, that means we should have these voltages available. So let's go with the first one. I'll just put this in the search bar. Go next. I want to find out where it's being generated. Okay, next. Come on, where are you being generated? Okay, these are all input powers. We were looking for an output power. Yes, I think this is the EC. Okay, well, this is the IC then, that is generating the 3 volt always, which is here on pin number 4. You can see that, and this IC is also generating 5 volt always here. So on pin number 21 we should receive 5 volt always, and this is also 3 volt always on pin number 4. However, thing to remember is these two voltages are regulated powers. So these regulated powers, if you see here, 5 volt always is here and 5 volt always is here also. They are coming after the coil PL3502, which we just checked, and PL3501, 3 volt always is there also. So these are the regulated powers and they are coming, but what is not coming is this is not coming. You see here LDO3, so this is what we were looking for, LDO3. So we were receiving less voltage on the battery pins, and this is what is the first power. Even before these powers are generated, 3 volt always is generated here. This is a regulated power, and 5 volt always, which is a regulated power again. But even before these two powers are created, LDO3 is generated before those two powers. So how this IC works is, I can show you here. So is a V20B, so is a 20 volt coming, and in this IC here, and EC on signal comes from the Super IO enable 1. We have a power good signal, so we can check if the power good 1 is okay. Power good 1 is for this power here, 3 volt always. So this power grid is for that PL3501. Next, our power good 2 is here, and this power good 2 is for plus 5 volt always. Okay, and you can also see we have a LDO5 on this IC also, which is the 5 plus 5 VLP. So the LDO power is mentioned as VLP in this IC or in this schematics. What we are going to do is we will check where this IC is, and this is called PU401. So where we checked in the schematic, those two coils, they should be there. So I will check the pin number 5 and pin number 20, and we are already receiving the 3 volt always and 5 volt always, so this is not something to be concerned about. But this 3 VLP plus 3 VLP is something to look at. Okay, let's go back to the microscope, and okay, so insert the power back in. So pin number 11 is the input power to this IC, which is 19 volt, you can see, and this 19 volt is coming to this pin. The next we were looking for is the pin number 21. So pin number 21 is going to be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this is going here. So we are receiving 5 volt LDO, no problems. So the pin number 4 was the 3 volt always. This is pin number 5 was the plus 3 VLP actually. So we were looking at the pin number 5. So 1, 2, 3, 4, 5, and you see here we are receiving 2.4. So this IC is not generating 3 volt LDO here, and these are the regulated powers that we were talking about. You see 5 volt always is coming, and then we have 3.3 volt always is also coming. So this IC is generating regulated powers. This IC is also generating 5 volt LDO, but this IC has problem generating 3 volt LDO. So, and you can see that is 2.4 instead of 3.3. So this is where our problem could be. Now this could be for many reasons. We will check this the leakage, or you can say that this the less power, that this is the reason that if this IC had generated the 3 volt LDO properly, then we would receive 3 volt LDO at the BIOS pin number 8. The battery pins, Super IO pins should have that 3 volt LDO. The power switch is also using the 3 volt LDO. So if this LDO power is not generated, then your laptop won't power on. So what we are going to do now is we will look for if there is any shortage on this capacitor. So something is not right here, so we need to diagnose it. Put the multimeter in the beep range. And you see here we have a shortage on 3 volt LDO line. Now this could be because of this IC. What we will do, if when I remove this IC, because this IC is responsible for generating the LDO voltage, either this IC is having this problem, or it is also possible that wherever this 3 volt LDO is going, somewhere down the line there is a problem, and that's why this IC is trying to generate 3 volt LDO, but because of the shortage the power is going towards the ground and we are not getting the all 3 volt that this IC has already generated. So but to clear this situation, what we will do is we will remove this IC first and check if this IC is responsible for the shortage. It's a Lenovo's 3 and 5 volt regulated power IC, and let's remove it. Okay, now we will test that capacitor again. Let's check it. Beep range, and we still have the shortage. So in this case we know that the IC was not responsible for this short. Now what we will do is we will inject power to this capacitor, because 3 volt LDO is going to so many places, is difficult to find. So that's why we will need voltage injection for this. Let me find where my cables are for voltage injection. Okay, let's do this. Okay, since we know that this is a 3 volt LDO line, we don't need too much power. We are not going to inject 30 volts or 20 volts on this capacitor. For voltage injection I have already made another video. You can check in the description. I will leave a link for that voltage injection method, how to inject the volt properly, because while you are injecting the power you could damage the board also permanently. So you don't want to do that. We want to find the fault and not damage the board. better. Okay, for this instance I will set my power supply to set to 3 volts and 2.5 amps. Okay, so this cap was showing it was short, so I have connected this is the positive to this capacitor, and I will power off this because I want to test. Okay, I will use my FLIR camera for this. Okay, my FLIR camera is ready now, and you can see this power is set also on 3 volts and 2.5 amps, and it's off at the moment. And I have connected those red wire to the capacitor, and black crocodile clip is connected to the ground. I will give the power, and hopefully we will see something light up on this FLIR camera. So I can see on the power supply, you can see that is gone red here, look. So that means it's detected a short circuit. However, on FLIR camera I don't find anything heating up here. I'll give a power again. I think, let's see one more time. Give power. So this area is heating up. This area is heating up, but there is nothing here. So I will flip the board round, remove this, and let the capacitor connected there. Ground, connect. Okay, now I'll give the power again. Okay, so this is the other side of the board, and hopefully we will see something light up. Oh yes, oh, we can see in that corner here you can see something just lit up. So I'll give a one more time, we'll try, and you can see here this is lighting up. This is our Super IO here. So I'll power off. Right, so what we found out, that there is something wrong with the Super IO, and this is causing all the voltage to go to the ground. And I'll just remove it. Okay, but remember we don't have the IC here. So this Super IO was heating up, this one. Whenever we have any problem with the 3 volt LDO, most of the time the first victim of a short is the Super IO. So if your 3 volt LDO line has gone down in voltage or is causing short circuit, most of the time is the Super IO that goes faulty. Now in this situation, our problem is the Super IO. Now this, I'm quite sure it should be a programmable one. We could program this one, but availability is another issue. So let's see in the microscope the number of this Super IO first, and then we will proceed with the repair. Okay, it's a Lenovo IdeaPad L340. Now I will just check in the UE1. The number is UE1. So I'll go in the schematics first and check UE1. Okay, and we have UE1 here. Sorry, you are not in the desktop. I'll take you there. So this is our UE1, and the IC is IdeaPad L340. So this is our IC. Okay, I mean, before I want to remove this IC, I want to confirm that I have this part available. Well, this is the trick that I was talking to you about. How do you find that if in your faulty boards you have this IC available? So if you go in advanced search here, and I will press new search here. Okay, now this is how I have set it up. So what I've done is I have made a folder with the schematics of the boards that I have in stock. These are the faulty boards. So let's see, if I go in the Google Drive here, I'll browse it, and my drive, available boards. So these is kind of a small database that I have made for myself, and I have in available boards, working boards and faulty boards. So I will select the faulty boards first, press OK, and I will search for this name, which is i8586E. I'm taking this this is the part from this the board which the IO board which we think is faulty, and I'm just going to press search. And if I have this IC available in any of the faulty boards, then I could go ahead with my repair. Otherwise I need to order it. So you see, we have some boards started to come up, and we have this IC available in 3 faulty boards. So the first one is Compal NMA271, ACLU1 and ACLU2. So the similar one is the next board. I think I have 2 of these boards. So I have another one which is Lenovo IdeaPad S145 LFC FS441. So I have this IC available in these 2 boards. So you can see here is mentioned here. So I know that I have this IC in stock. Now I can remove this Super IO and grab it from the faulty boards, but we will need to program this IC as well, because that IC which we will extract from the faulty board is programmed to a different motherboard. So let's go back to the microscope, and I will try and extract it. So my eyepiece is gone a bit blurry. Yep,
better now. Put some flux. You can, because this is a faulty IC, so you can use any temperature, but with a working good IC, try and go on the corners only, not in the middle, because we are just taking this pads off. So it's daisy. Okay, I think I have just made a mistake here with some of the components. This cap comes in. Put some. So the IC is off, and now we will put that 3 and 5 volt IC back in, because that IC was okay. It's just sitting. Okay. Another
thing we can check now is this capacitor. Now we will check if we still have the shortage on this cap. You see, the shortage is gone now. There's no more short on this cap. So the Super IO was causing a short, and the voltage, it was drawing more voltage than it was supposed to, and because it was short to ground, this IC was generating 3 volt LDO. However, because it was drawing more power than it was supposed to, so other parts of the board was not receiving the 3 volt LDO. So this is done. Now I'll pause this video to get the part out from the faulty board. Okay, I have extracted the the IC from the faulty board. So this is our IC, the faulty one, and this is another IC from a faulty board. So I will just move this one away. This IC has some dirt here. I'll clean this before I install it. Because it will be harder to clean. Okay, I can see something here. I think it's some flux. Clean now. Okay, one pin I can see is a bit not straight. This is bent. Just make it right. Okay. Oh, this IC is okay now. Let's check the board. And so this is the number 1 pin of the Super IO. I'll just give it a clean, a very good clean. I want to remove all the residue from the flux. Better now. I think my flux has ended. Is it, or is it not? Don't know. Oh no, it's still got some. I thought it's just finished. Just needed more power because of the cold. Okay, let's. So you can see here there is 2 dots on this IC, one big and one small. So the pin number 1 starts from these smaller dots. So that's one more thing to remember. And alignment of these is a bit tricky for the beginners. So when you do it first time, it's gonna take you a lot of time. But with experience, when you'll do it quite a few times, then it will become easier. Only thing is, if you adjust from one corner and then go for the next corner, then should be okay. Like in our case, is almost done now. Yeah, so it's aligned little bit from here, so I'll just adjust this part as well. Yeah, it's all good. Okay, yeah, it's better. Okay, now when the solder is melted, I'm not going to touch it. I will touch it when it's the right time. Okay, remove the air. Okay, now I can press it down and then bring the air back in. You can see it's nice and easy now. So the Super IO is installed. Let it cool down.
So, problem here also. Let's check. 1, 2, 3.
So this Super IO is installed properly now. It just took me some time. It's because some of the pins were not connected properly. The thing is, once you have a problem similar, you have to do all the pins one by one and make sure they are connected properly. Okay, now we will check the shortage on that capacitor. Let's see. Okay, so you see the shortage is gone now, but we have another problem, which is that this Super IO is not programmed for this board. For that we need to use the SVOD programmer. I will get the SVOD programmer set up. Let's see. So this is the SVOD programmer, and this is how you program the Super IO with these cables. There is some ZIF sockets available also, but this thing also works. Right, let me take you to the desktop now. Okay, so let me launch the SVOD programmer, and we will program this Super IO now with this programmer. I've already made the connection with this cable. What we only need to do now is select the motherboard pinouts. Okay, we'll select the ITE, and then next we will select the motherboard, which is NM-C361. It already came here, and this is the ground connection with the micro USB cable, and it goes from here to there, any of the USB port, and we will press OK, and it says check pins OK. So that means the connection is good. At this point, make sure your charger is not connected to the board. So it just says check ground programmer to the motherboard, that there's a good connection from motherboard to ground. And now it says to plug in the power. We'll plug in the power, and then we will read ID. Okay, what happened? It gave me some error, so it just closed. Okay, let me relaunch it. I think something may have gone wrong. Remove the power again, yes, and select the ITE 3 point, select motherboard NM-C361, which is right, and unpower, check pins OK, check ground OK, and now plug in the power. So we plugged in the power. Okay, so we will read it in hex view. There is already some data, but this data is from the previous board where we took this IC from, this Super IO from. So what we need to do is write the file, which is this one, ecite.bin, and I downloaded this file with the board number from the Winafix website. So when you type in the board number, you will find this file there. You need to have a payment made to download those files, obviously. And okay, just press right here. Start writing this ECITE file into the Super IO. and while it's writing it will also erase, blank check and verify, so I don't have to do it separately. It will do everything in one go. So now it's just verifying the file and it's verified. Okay, just we will do one more thing. We will just read this file and we will check in the hex view that there is some data available. So if, as long as this data is there, that means some binary files have been or some hexadecimal file have been written to this IC. This is a hexadecimal data. Okay, I'm just going to power it off, close, and I will remove the power from the motherboard first and then from SVOD just disconnect all this. Now the moment of the truth, let's connect the fan, connect this power, and let's see. We should have a fan spin. Yep, we have a fan spin. So the motherboard is start working. One more thing we can check is the 3-volt LDO. Let's go back to the microscope. So the microscope is on, and we'll give the power, and we will check if we have a 3-volt LDO available now. The fan is spinning. This is our 3-volt LDO. Before this was this line was short and we were receiving 2.7. This is our 5-volt LDO, which is also available. This is regulated power 3.3 volt, which is available now, and 5-volt regulated power is also available. Oh, sorry, you didn't see that. This is the 5-volt and this is the 3-volt regulated power. Our 3-volt LDO is here, 5-volt LDO is here. So we'll check on the battery pins if we have those SD and SCL available. They come with 3-volt LDO, so we have the 3-volt LDO available. SCL and SDA line, one of them is battery present also, so they are all available now. So this in theory this board should power on now. What we need to do is just connect the display and check if we have a good display now.
And we need to connect the LCD connector and the keyboard connector. I believe this is the backlight connector for the keyboards. Power in, finger cross, should power on, give some display. It's going to reset itself a few times. Do we get something?
Yes, something happened on the screen and we have a display. You see here? Okay. Wow, we have a display. Good. Okay. I want to test with the SD card. SSD card, sorry. Just push it in. Keep it that way. And we will see if it powers on. Come on, give me some display. Yep, we have a Lenovo display. Now you can see it has powered on. So this job is done. This laptop is fixed, and you can see we are in the powered on situation now. Yeah, so this job is done. This is fixed.